sometimes occasionally call her Karen. That's okay too. Okay. I have been doing this a while, so I'll often refer to it as a gymnodidium. Now, gymno means naked, which is because it doesn't have any plates. Most dinoflagellates have little things around them that make them hard. This one doesn't. It's entirely naked, and so it needs protection to stop things eating it, and that's why it's a little bit more feisty than most. Okay? But out of that genus, this is the most benign. Okay? If you were to get a gymnodidium or a Corellia bloom, this was the best species to get. So, high five, well done. Okay. They have a huge genome, and one of our biggest problems when you ask people about this species is its genome is, last time I looked, and I'm not a DNA scientist, over 1,000 times the size of a human's. So that little tiny packet has all of these genes, and more than half of them are dark. In other words, they're not active right now. So this little, beautiful, gorgeous algae arrived here. It's not native to Australia. As the current research says that it originated from somewhere near Japan. And it has arrived in every single port of the world. We've had it here since the 80s that we know of, that we've been documenting it, but I am not that old and don't go back before then. So I don't know how many were here before. So it's been here quite a while, and what we know is that in each location it goes, different genes are turned on and off in response to the environment that they're in. And so we have 20, and someone's going to correct me, I'm sure, there's 28 strands or strains of this that we know about worldwide, and each one has a slightly different profile. But of course there's not a lot of research then on something that cryptic and that small, and it's not very visible. And so there's a little bit of educated guessing that goes on when we're talking about this. And so we have to talk about the species as a whole. This one might be slightly different, and that's okay, and we just have to accept that. Now, each little tiny algae only lives 3 to 5 days. So your bloom's been here, 6 weeks almost? Yeah, and so it's had a lot of algae cells grow and then die. Okay? Each time you go through a generational shift, you have the opportunity that you get different species pop up, because there's thousands and thousands of species. But this species happens to have something called allopathy within it. It puts out a chemical that kills everything else around it, and it does that to stop other things growing and competing. Despite that, Rolls and I were finding lovely little bacteria on the dinoflagellates today, and I've been told already, Okay, your counts were varied. The sample that Perry and I were given from Victor Harbour was 27,000 cells per milliliter. Speaking with the various department staff who's run me over the last few days, the counts that have been coming in have been up to 600,000 cells per milliliter. So that's almost a million. Coffin Bay in 2014 got up to 16 million cells per milliliter. So your density is not high, that's why you're not seeing it very much, but the area it covers is huge. At the moment, it's around 4,500 square kilometres, or the area of KI for something easy. Now, this is a common one. Now you've got to remember, every single profession in the world has a different way of using words. The number of times I've seen an ecological phrase used in a completely different way in business, and don't even talk to me about how my accountant uses ecological phrases. So, given that, you will hear the folks from SA Health using terms like toxic and harmful, and you'll also hear them using a term called endemic. And each one has a very different meaning in the situation that they're using it. So, when you're talking to a medical person, harmful is the knife, okay? It can harm you. It is not toxic. The poison is toxic. All right. So when you hear them say, your species is a hat, but it's not toxic, what they're saying to you is, your species is harmful. It will harm you, and it will harm fish that you value. okay? But it is not toxic, it is not a poison that stays in your body. So it's not cyanide, it's not, radioactive, it's not something that you will consume and then you'll continue to get sick afterwards. And so that's why they say you'll get better once you take the exposure away. And in different people that will take longer or less time. If you're lucky, you wash yourself and it goes. If you're not lucky, your immune system responds to it and you get a longer response, just as you would from a cold. Cold is once again harmful. The cold virus is harmful to you. It is not toxic. Okay, so hopefully that clears that one up a little bit. Okay, what they do have in them, and it's what's causing you all the itches and the coughs, and it's also killing the fish, is something called reactive oxygen species, which is a terrible phrase, which no one actually knows what it means, so we all ignore it. But it's a really important thing not to ignore because it is... I'm getting told that I can do very good. The thing about reactive oxygen species is there are a very small molecule that includes oxygen that is missing a proton. So basically, if you can imagine it, what is being aerosoled is close in chemical formulation to hydrogen peroxide, just without hydrogen. Okay? So you are breathing that in, and it is reacting with the cells of your lungs. And it is doing what peroxide and related chemicals always do, which is it cleans up and it oxidizes those cells. And so I've got a little diagram here for you that shows you a healthy cell, and then it's exposed to reducing oxygen, and it destroys some of the cell membranes and things. And this is just what happens. It damages the cells, and if the cell is older and damaged, or your immune system responds to it, or all sorts of other reasons, you may get that better or worse. So your young folk won't get it as much, and those of you who have lung issues like I do will get it worse. Now, the kicker is, and this is why you're getting your fish dying, is it has a stronger response on cells that are not used to being exposed to high amounts of oxygen. So when you're looking at the oxygen that you breathe, hopefully you're breathing more than 21% oxygen. Okay, in the air that you breathe. Whereas your fish are breathing 4 milligrams per litre to 12 or 16 or 19 milligrams per litre, right? So we're talking about 1,000th of a gram in 1,000 grams. This is nowhere near 21%, okay? And we know that these reactive oxygen isotopes damage cells more the less oxygen is in the air. Okay? So when your fish breathe them over their gills, it corrodes their gills. And they get an immune response to it because all of us produce these chemicals as part of our immune response. And so it's a really fascinating thing to look at, but that is why everything that has gills, carefully adapted to be highly good at extracting oxygen from a very poor oxygen environment, is now extracting these highly reactive oxygen species from where we really shouldn't. Okay, so that is just why your fish are dying and you're just coughing. Okay, hopefully that cleans that up. Most of this I have covered. It was found first in Japan in 1935. These are the list of countries that blooms of this particular species have occurred. It's all over the place. Major issues in the Gulf of Mexico, or should I say the Gulf of America. The species, it's very equal opportunity. I like the species very much. There's no doge here. It kills absolutely everything that breathes water. And so that includes your sharks, but they are bigger, so it takes longer. And it includes your rays, your fish, your abalone, your lobsters, which the fishermen down at Roe were telling me about, large amounts washing up, absolutely everything, right down to your cockles. It also kills a lot of other zooplankton and things which your whales feed on, which is heartbreaking. Kills by this species alone on a single kill have been worth more than $20 million in damages overseas. And so this is going to have a major impact on your fisheries as well, which is important to this area. It it is mixotrophic. Some people have been saying to me it's always in the top of the water, and of course it isn't, because this thing swims really, really, really fast, and it also can consume other algae and bacteria. But the thing it loves, and what sets off a dinoflagellate bloom rather than a cyanobacterial or a diatom bloom, is the presence of something we call dissolved organic carbon. So it's organic food, sludge, aeroplane jelly, stuff that's generated when things rot. That's what this eats. Okay? It also photosynthesizes. That's why we call it mixotrophic. It eats more than one thing. But because of this, it doesn't need as much bioavailable nitrogen as many of the other species require, because it can access the sludge. It can, of course, lower the oxygen in the water overnight, and it has occasionally been implicated in dolphin deaths overseas, but we think that's just from constant exposure to it. They don't breathe water, so it's sort of a bit complicated, but that's a bit of a question. I mentioned earlier, this is not the only bloom, and I think that's a really important thing to remember. You are not alone. The entire state's pretty much experiencing a bloom of something at the moment. Okay, yours is the toxic one. No, not the toxic one, the hazardous one. Okay, so at the moment though, Coffin Bay, there's a photo from it yesterday there. A friend of mine was in the water taking video footage. They've had to close the fishery down, the oyster fishery, due to another different dinoflagellate that's pictured at the bottom, which if you eat the oysters from there at the moment, you'll get food poisoning. So that's another species. It's caused by similar things. I have pictures of this species hitting the Edithburgh jetty and the huge deaths that have occurred over there. Of course, Kangaroo Island has been hit. Franklin Harbour up near Cowell turned bright red. Like literally, it was a bay of blood. But by the time I managed to get someone there to check it, the bloom had passed. But we believe it was a different species, possibly, well, the jury's out, we're really lost. Something, because we couldn't get it sampled, but it was gone within 4 days. And so sometimes they come and they go. All right. And going the wrong way. Now, there's a lot of theories about salinity and heat and this species. Okay? This is your heat map. Basically, this tells you exactly what you need to know about why this is blooming here right now. The species replicates at a certain amount of speed. It doesn't produce cysts. What it does is each cell subdivides. Now, if the water is about 25 degrees and the salinity is around 30 grams a litre, the biomass, the amount of it in the water, will increase by 1/3 every day. Okay? This is as long as there's enough nutrients. But that's what it really, really likes. It will tolerate in salinities pretty much all the way from about 22 grams per litre, which is why the coorong in the lakes, will never get it. And it will tolerate up to around 36, 37, now I'm being told, grams a litre of salt, okay? But it won't tolerate desal discharge, and it also requires the water to be quite warm. It doesn't tolerate cold water, so you're really looking at that temperature range of around 18 to around 27 degrees. Now, what Rolls was using and sharing quite often was these chlorophyll maps. I have the dates on them, you can come look at them later. What you can see there is the bloom building between the end of February and now. There's a few riders on these. This is a particular app which averages the chlorophyll in the water that it can detect. It's an indicator, it's not a measurement, over a 3-day period. So it tells you what you're seeing what its satellite is seeing over a 3-day pass. There is many things that cause it to go red. So all of your seagrasses, all down to 10 metres of depth, all of your macroalgae, all of the stuff that grows on the mudflats will also trigger this. So you need to look at it with that in mind. It's only a plankton bloom if it's in deep water. If the water's more than 10 metres deep, then you're comfortable that there's that on this. The other thing is that there is at least 200,000 other species it could be. Okay, but we know here that it's pretty much all that species. Now, this is the iNaturalist maps of what has died. The interesting thing about iNaturalist is that there is around each one of these brown polygons is a current project being run about the bloom. Different groups and different researchers have set them up. You don't need to know about those projects. You just log on to iNaturalist, log it as a marine creature, and log it as dead. Okay? Then every single one of these projects will get it. Now, the ones that are triggering the projects at the moment are the red spots. They are zones. The deeper the red, the more animals found. Okay? So that's the distribution of the kills. And at the moment, it's pretty much just this species that's killing them at the moment. So that gives you a fairly good map. And this is the number of species. So far, 123 species have been logged, and there's been over 500 observations logged. I'm sure all of us could add to that a lot, and that would be much appreciated. Now, why is it occurring where it is exactly? Okay, this is a picture of a Californian frontal bloom. This bloom is caused by the river water. But I think most of you can see that if the chlorophyll is the bright green in this image, the chlorophyll is not in the river water. It is in the seawater. And the reason why is this species swims between them. It lives in that zone where things are mixing so that it can move backwards and forwards. It also moves up and down. Okay? So it's what we call a frontal bloom. It's a well-known phenomenon, and you'll see why it's a well-known phenomenon shortly. Okay. This is why Victor Harbour is known for its whales. Victor Harbour is known for its whales because it is on the continental shelf edge and there is an upwelling. That upwelling creates a mixing zone. The Gulfs are warm and hot and salty, and they let lots of dissolved organic matter out into the seawater, which wouldn't naturally get that amount. It hits the seawater, it mixes, and you get an algae bloom. There is always an algae bloom there, it's just a different species at this time of year. And then your krill will come in, they will eat the algae because it'll be a harmless one, and then your whales come in to eat that. Really fundamentally, basically, but you can see in both of the maps below, the blue whale sightings follow that, and so do the right whales. I am so done. Very good. This is your surface temperature map for tonight forecast. Okay? What this species likes is anything above the yellow as far as temperature goes. So looking at this, you would think that it would be up in the Gulfs, right? And it's the same for the bottom. That's the bottom temperature. The previous one was the top temperature. This is the salinity. So unfortunately, what it likes is anything in the blue, green, and maybe a little bit of yellow. So you can see what's keeping it out of the Gulfs at the moment. The reason we're not having a bloom of this species in the Gulfs is that it is too salty. And hopefully it stays that way for long enough for the bloom to bugger off. Okay, but this is the conversation that oyster growers and I are having at the moment. One of them is at Stansbury, 2 kilometres south of him. Everything is dying. Where he is, everything is healthy. The only reason is he went over 37 degrees, 37 PSU. And this is Victor Harbour. And this is why your bloom comes and it goes. Because the top one is temperature, and the next one down is salinity, over time and over depth. So depth is on this axis, time is on this axis over a few days. The colours reflect the amount. The hotter it is in the top one, the more yellow it is. The saltier it is, the more red and yellow it is. Okay, so you can see that this species moves up and down in your watercolour, reflecting where the tide and where the current currently is. You can look at this and go, conditions are not right for it right now, we'll go swimming. It's a perfectly justifiable response. That's what the boys are there for. Okay? Keep yourself safe. Now, why is it occurring this year? If this species has been here for most of our life, the reason why it is here this year and not any other year is that we have had one unbelievably hot heat wave since September. Now, in September, the upwellings finally stopped down the southeast. They had run for 7 or 8 months non-stopping. When they stopped, things started getting hot really quickly. By January, I was getting reports from fishermen down there, and I didn't go down, and I should have, of large amounts of macroalgae dying. I just got back from Europe, so I didn't have the time. And the fishermen were complaining of boils all over their bodies. Okay? I didn't go down. I should have. When I went down there a few weeks ago, the fishermen showed me their arms, and what they've got is what we call a saltwater boil or a diatom boil, where the glass of the diatom shell goes in and it makes a foreign body infection on your arm. And it takes 3 or 4 weeks to be out of water before they go. And what you need to do is you need to wash it off. As soon as you get in the water, as soon as you hop out, you wash it off. If you leave it on your skin, you'll get the boils. Accompanying that was one humongous dieback of macroalgae and seagrasses. And so from January onwards, they have had huge beds of seagrasses and macroalgae, so kelps and things rock up on their shore. Completely out of season, this would normally happen in winter. Now what we're seeing is that it is rocking up in summer and autumn, and it is rotting in an ungodly mess that is stripping the oxygen out of the water. You can walk to the end of the jetties and not get away from the ooze in the water and the brown decaying bits of rotting stuff. And the fishermen took me out on their boats with drag nets, and we were getting no krill, no sea fleas. You know, you go in the water and you get those nasty little things. None of that. We usually see those in association with rotting seaweed. None of that from Boatswain's Point north. And so, and that's caused by this unbelievable, if you look down here at 2005, these are all April. So they're every year, from the blooms that I saw in the Onkaparinka in 2013, when there was the last big heat wave, through to 2005 now. You can see that this is the hottest on record. And it is... Okay, what can we do about it? And they're discovering I'm getting really good at anyway. The South Australian Gulfs were once full of benthic life, seagrass, pinna, oysters, and we dredged those out. We've killed most of them. There is a very small portion left. When you saw that video, we talked about the kelp forest in Tasmania that I swam in as a baby being down to 5%. Okay? We've done the same here. Now, if you have stuff growing on the bottom that is complicated, you will not have plankton on the top. And the reason why is they strip all the nutrients out. When they strip the nutrients out, they keep the water temperature cooler because the water comes down and through. Whereas if the sun hits a plankton in the water, it absorbs the heat. Okay? And so if your water is clear, it is cooler than if it is murky. Okay? Dredging, pollution, sea urchins, and invasive species. We have almost exterminated the marine life in our gulfs. This heat wave really did a number on them, even more so. So if we can find a way of restoring these, not only is it the biggest opportunity we have to get rid of all of that carbon that's causing the climate change, that's causing the huge heat waves, but it also helps us manage the impact of the climate change. It is incredibly important, and I am almost finished, I promise, that we stand witness. I am a Quaker, and you can tell when I'm here, but two, is that it's incredibly important that you record it every time you see something wrong. PIRSA do listen. They do record your fish watch calls. You might not see them respond, but they at least log it. Okay? It is logged. Every single call and email is logged. Okay? And in the end, those of us who go back in and ask them for them will see there is X number of calls. It's a nightmare, I know, but keep doing it, please, because it is important and it also shows off that we need resources in this area. Log everything you see on iNaturalist. I don't care if you don't think it should go up there, put it up there anyway. There is some amazing work being done around Oz Ocean. They've got cameras and stuff in the water. You can actually look under some of the jetties. There isn't any around here, but any community group can put one in and they'll help you do that. There's things like Sepidis and colour recording of the water that's regularly done from jetties. There's Eye on Water where you take a photograph of water and you put it up on an app, and so on. And of course we are always here for plankton counts. It drives me nuts, but there you are. Okay, there are also things that we need to do at state and national level. Okay, as a community, we can stand witness. As a society, we can make a difference. We need now regular beach monitoring and all PCR testing to detect when these blooms occur so that you know fortnightly or monthly over summer on every public beach. We need to share data. It takes 20 minutes to do a plankton count. Yeah. That data should be out in less than a day. Okay? 18 hours to settle it. Okay. Less than a day still. Okay? This data is not secret, it's what we swim in every day. That data should be available. We need to learn to embrace uncertainty. We need to have public reporting of the blooms when they occur, and I've given an example of the Canadian one there, which is just mind-blowing. What they do is they let you report it and that becomes public immediately, versus when they've verified it, then it gets an extra mark on it to say that it's verified. We need to consider whether we actually need hazardous algae bloom legislation like many European and American countries, states have. We need to do climate change mitigation and we need to restore our nearshore coastal habitats.